And welcome back to another spectacular video in which you are going to learn about events. We're going to create this smart contract, example smart contract. We're going to declare an event. We're going to emit an event. And you see all these green lines. That's the event being emitted. And we are also going to do all of this using hardhat. So let's not waste any more time because your time is very valuable, because you need to learn about blockchain development and become a smart security expert. So what are events? So events are basically this thing you define in your smart contract. You can think of them as a type, a different special type, and you can emit those events. And when you emit an event, you basically emit some data. Let's say you have a crypto slot machine game here on your front end, and you want to generate some random number. This is an actual application I was building. I had this problem, and what you want to do is declare an event and emit whenever those random numbers are generated. You can do this with whatever kind of app you may have a lottery app here on the front end. Just in my example, it was a crypto slot machine game, and whenever you emit those events, you're basically emitting this data, and anyone from the outside can read this data, such as this front end over here. And let's see what's happening under the hood. And under the hood, whenever you emit those events, this data basically gets stored onto the blockchain, and it acts as a login mechanism, so you can go ahead and read those events into the transaction. So let's say you emit this event, so you make a transaction. You can go into Etherscan and see your transaction and your logged information. And this way of emitting data is way cheaper, or I should say this way of storing that data is way cheaper than storing them in a variable, especially if you are generating 4 numbers like I did with my code. And you can emit this data in a way that is very searchable, and you can later just search all of this historical data that gets created once you emit those events. And you can search them very easily if they're indexed, and you'll see what I mean by that later. So I already told you this, but I'm going to rephrase it so it makes more sense. When you emit event, as I said, you emit data. Basically, that's the point, that something happened on this smart contract. And when you emit an event, you pass, I haven't written here, but you pass arguments, which is the actual data, and you can read this data on your front end. And what this allows us to do is create real-world applications. How? Well, let's say this front end is your PancakeSwap, your traditional PancakeSwap website, and what you do is you use most likely use PancakeSwap for swapping data. Crypto, and whenever you want to exchange BNB or swap BNB for, let's say, cake, you're going to make this transaction. You're going to interact with this smart contract, and whenever the BNB is actually swapped on the smart contract, an event will be emitted. And what they do is the coders of PancakeSwap are listening to this event that's emitting here, and they'll just update your UI and say, hey user, you have successfully swapped your tokens. So let's go ahead and create our hardhat project. And in this project, we're going to create our smart contracts, and we can also emit the event. So we'll do everything inside this hardhat environment. So we're going to create a hardhat. And by the way, hardhat is, again, it's similar to Truffle. It's basically an alternative to Truffle. It's an environment where you can compile compile, deploy, and test your smart contracts. And I really recommend hardhat because it's pretty nice. So I'm going to open a new terminal, I have opened this empty folder, and what you want to do here is just do npx hardhat, and I have installed hardhat. I think you should have installed hardhat previously before you try to do this. But let's create, instead of a basic, let's create an advanced sample project because we want to become advanced programmers. And let's press enter for this. This is the project root. And yes, I do want a git ignore file. And yes, I do want those dependencies. So open your newly created Hardhat project and go inside this contracts folder. We already have a sample contract, but we're going to rename this, and let's call this, and this example is, by the way, from the Chainlink docs, so let's call this simple storage. I'm going to, of course, modify it a little bit, but not too much, because I think I'm showing you this because I think it's a great example. So this is going to be contract called simple storage, and we're going to delete all of the contents, and we're also going to delete this import because we do not need this. And also, before we start, I'm going to go into this hardhat config file to configure my Solidity version, which is going to be 0.8.7, and I want to do exactly the same thing inside my smart contract. And inside of this smart contract, we're going to have a number. Let me actually tell you what we're going to code. Basically, you're going to have a number stored inside this smart contract, and whenever we update this number, we're going to emit some data, the updated number and some other stuff. So let's go ahead and say uint to 156. This is going to be public, or maybe not, but we'll see. And let's call this favorite number, and let's assign this a value of 1. And let's go ahead and declare a function which is going to be change number, not store number. We're going to change this number, and to change this we have to pass the number here. It's going to be a uint, and this is going to be new favorite number. So let's call this new favorite number. And also this function, let's let it be public. I think external would work as well, and it actually may be better because external is, as a modifier, it's more restrictive. So let's go ahead and update this number, and we're going to say favorite equal to new number. And finally, we've got to the point where we need to declare the actual event. So, and you can declare events using the event keyword. As you can see, it highlights. And what now we need to provide the name of this event. The name will be change number, the same as the function, or let's call this store number. And you need to provide these parentheses here. I think you also need to provide this semicolon, and inside the parentheses we're going to specify the type of data that we want to emit. As you know, these events are being emitted. So now I'm going to define, we're going to emit a uint, and this is also going to be our old number, and we're also going to have, and we need to separate these by comma. We're also going to need the new number, and when I say old number, I mean this one. It should be 1 always, because this is the initial value, and the new number is this new favorite number that we're updating to. So also let's say old number, new number, and let's also emit the sum of those two numbers, and also we're going to emit the actual address that emitted or called this function. So address, and then say owner, or no, sender. Let's call this sender. So now we have our event, and now we need to emit this event. And you can emit event by saying emit. Everything's so simple, man. So also provide the name of the event, parentheses, semicolon at the end, and here inside of here we're going to emit those values. This is like calling a function, so to speak, and I'm going to use favorite number. This is the old number we have, and also we're going to emit the new favorite number, the sum, which is the favorite number, the old one, plus the new number. And also I'm going to emit the actual sender, which is stored at message.sender. So now I have just reordered this so it's more readable. So now we have this change number function, and whenever we call it, we pass this new favorite number, and we change the actual number, and we also emit this event. So this can really be even a real world scenario. So whenever, let's say, this function is called from your front end, you change a number and you actually want to emit an event that the front end can listen to, and then, you know, update the user interface. Okay, let's learn about an important keyword in Solidity regarding to event, which is the indexed keyword. And when you can add this here, for example, I can say indexed, and basically what this allows us to do is it allows us to index, and it makes this variable here, this argument to the event, more searchable, and we can more easily search it up on the blockchain. And you can add up to, you can make only 3 or up to 3 argument you can make indexed, and we are going to make this one as well. So let's say index. I'm going to save this, and I'm not going to go too much in depth about this index. That's all you need to know, and you're going to learn about it later in the video when we actually see the transaction on the blockchain explorer. Okay, so now that we have successfully developed this smart contract, let's go inside this scripts folder into our deploy.js, and here we have some this is a JavaScript script that you can run, and usually this is how you would deploy contracts, interact with them, test them. Everything you do in terms of interacting, deploying, testing smart contract, you do it with JavaScript. So let's go ahead and delete all of this, because we're going to write it from scratch so we can learn more. And what we're going to define here is an async function, and this function is basically what we're going to run. This function is going to deploy our smart contract, and I'm going to say async function. Let's call this main, define the body, and we want to call this function here using main, and then we want to catch some possible errors, because as you saw, this is asynchronous, may have some errors. Let's go into catch and then specify an arrow function here, and this arrow function, this is basically what's going to be triggered after this main function is called and this catch block. So let's pass an error here. This is just an argument, and what we're going to do with that error, we're just going to console.error, and this is the code recommended by Hardhat. So I'm just copying here. This is what they recommend you to do. and they also say process.exit code equal to 1. This is what they do, but I'm not sure what this means, but it doesn't really matter because this is what we're writing here is the real juice. So let's say const hardhead RE. I don't know what R stands for. Hardhead real or runtime environment, I think it is. And we're going to require, so say require the actual hardhead project or package, I should say. We're going to come here and compile all of the this smart contract, and you can do that by saying await. And since this is an async function, you can say await, then HRE, the actual package, and then call this run function, and we want to compile our smart contract. So let's go ahead and say const simple storage, and this is our actual factory, and we're going to get this by using the package.ethers.get contract factory. And this is basically a factory that can basically generate new smart contracts instances from our simple storage. And here we want to create a factory for our simple storage contract, and then I'm going to say simple storage, define another variable with lowercase s, and say equal to await, and then we're going to await for this factory to deploy our smart contract, and we're going to call by calling the deploy method. And I want to also await and for when all of the data, when it's actually deployed. So we're going to call simple storage.deployed. Deployed means just everything is finished, the transaction is confirmed. This is basically saying, hey, deploy my contract, and this is saying wait until the contract is deployed. Or at least that's how I think of it. So let's console.log, and we can say smart contract was deployed to, and give it an actual address. So let's access the actual contract by going into simple storage and print out its address. And if you don't know what blockchain we are deploying to, that's a really good question. So we're deploying to the local hardhead blockchain. So when you do this sort of stuff, create hardhead project, immediately, I think after you just execute this file or something, the hardhead blockchain is basically installed, ready to go, and we're deploying this smart contract on this local development blockchain. So let's test if this works, and we can run this script that deploys our smart contracts by saying npx hardhead and then run, and then we need to specify the path which is inside script and deploy the actual file. So let's click on enter. So we have now successfully deployed this smart contract, and you cannot take this address and see your contract on a testnet, because as I said, we're deploying this only to our local development blockchain, and our local development blockchain does not have a blockchain explorer. So now that we have successfully deployed this contract, let's go ahead and see the transaction response. Or actually, let's call the function first. So let's go ahead and say await. I access the contract, then say store number. This is the function, I think that's the name. Not really. The function name is change number. So let's go ahead and store change number, and currently, initially, it's set to 1, but we're going to change it or update it to 2. And now we want to take the transaction response from this transaction. So let's define const and say transaction response. When you create a transaction with as we did here, what you get a transaction response, but this transaction response you get this and the transaction still may not be included in the blockchain yet, and therefore it doesn't know what logs will be emitted. So what I'm going to do is wait for the transaction receipt, which is basically a confirmation that this transaction was minted on the blockchain. So to get our transaction receipt, we just have to call a function on this, call the wait function on this transaction response. I'm going to say const transaction receipt. So let's go ahead and print this out and see what we get. We should get, since we're calling this function into this transaction, we should get the logs or the transaction or the data from emitting this event. So let's go ahead, print the transaction, the transaction receipt. So now if I run this script and wait a little bit, and by the way, a little trick while we're waiting, we can always expand this terminal by clicking on this error, and we made a mistake where we didn't await this transaction. That's why we're getting this promise over here. So let's call this, let's run this script again, wait a little bit, and bam, this is our transaction receipt. And we have a lot of information here about the actual transaction, but what we need to look for is events. So let's search events. So in this receipt, what we have is an array of events, and we have only one event object because we're emitting only one event here, not two in our function. And here we have the actual arguments that we're emitting inside of an array. So let's go ahead and print the first argument. So you can print the first argument if you access the events array, and we're going to access the first events object because we're emitting only one event and it's the first one. Then we will access the arguments, and then we will access, let's see, the old number, and let's convert this to string. So now I've again run this script, as you can see, and the old number is 1. You'll get 2 if you go ahead and print the new number. So for now we're deploying this on our local development blockchain, but what I want to do is to deploy this on the Kovan testnet so we can see it on the blockchain explorer. So let's go ahead and enter this config file, and since this is an advanced hardhat project, we already have set up or configured this Robson network. But what we want to do is deploy this on the Kovan testnet. So let's say Kovan, and here you have to connect to this Kovan testnet, you have to specify the Robson URL and the private key. And since I want to make this as safe as possible, we're not going to, you can use the private key of your MetaMask account, but what we're going to do is check out Vanity, which actually generates an account for you if you just click on generate. And if you click here, you get a private key and a public address, and this is the private key we're going to use to deploy our smart contract. And to connect with any sort of blockchain, you have to have a node, an actual node running on that blockchain or testnet. And you can do this, and you can run it of course locally, but it's way easier to just use this service called Infura and go ahead and sign up. It's totally free, and we'll go ahead and start your first node as I have here. And you have some options here to choose your apps endpoints. We're going to use Kovan, and let's copy this. This is what's going to connect to our node. So let's go ahead, and here we have an env example, but this is just an example. So let's create an actual env, and let's paste this here, the Kovan link, and then we're going to paste this private key. And now instead of accessing this Robson URL, we're going to say Kovan URL, copy this, and actually declare it here. The syntax is you just type the name equal to the actual value. And now I'm also going to copy this private key and say private key equal to my private key. So now to deploy our actual contract, we again need to run this deploy script, but instead of running it like so, this is going to deploy us to the local blockchain, and we want to deploy it to the Kovan testnet, and that's why we were configuring it here. So we're going to use --network Kovan. And jokes on you, we're getting this insufficient funds error because we do not have any Ether in this contract. So let's copy this public address, go to a faucet to get some Ether. We're using the Kovan testnet, paste this here, click on another robot, and send your request. Now if you run the script again, the contract will be deployed to this address. And if you look up that address on the Kovan testnet, you're going to see we have successfully deployed this or created the contract and called the change number function. And if you go to the actual transaction, which calls the change number function, go inside logs. As we said, these are the events log, and you have two sections, topics and data. Topics are our index parameters, and here at index 0 we have the transaction signature, and here at the index 1 we have the old number. As you can see, it's 1. This is the initial value we set, and then we have at index 2 we have this 2 number. Then we have the data, which is our third index, because these are not indexed, they're inside this data section. And you can see the actual number and address if you click on address and number.